Hello children, welcome to physics online classes. Today in the second part I would like to discuss about effect of temperature on resistance. Coming to effect of temperature on resistance. Effect of temperature on resistance. So effect of temperature on resistance is given by this formula RT, means resistance at T temperature, which is equal to resistance at 0 temperature 1 plus alpha T plus beta T square. Okay, understand? Okay, here in this content, in our plus 2 physics content, they given one formula. Alpha is equal to RT minus R0 divided by R0 into T. R0 into T. Here in this given formula, RT means resistance at temperature T. R0 means resistance at 0 degree centigrade. 1 it is a number. Alpha is the temperature coefficient of resistance. Temperature coefficient of resistance. T temperature in Kelvin or centigrade and etc. Okay, here alpha, beta are called temperature coefficient of resistance. Here temperature coefficient of resistance is defined as the change in resistance per original resistance per unit temperature. So this we can write RT2 minus RT1 means resistance at temperature 2 minus resistance at temperature T1 divided by RT1 into T2 minus T1. Okay. Temperature coefficient of resistance is defined as change in resistance per original resistance per change in temperature. The SI unit is per Kelvin or Kelvin inverse. Okay, here the temperature coefficient of resistance alpha for metals positive means we know that resistance increases means by increasing temperature increases means resistance also increases. Alpha for metals positive means conductors, aluminum, copper, like that. So alpha for metals is positive. For insulators negative. For alloys alpha is very small. So what is the temperature coefficient of resistance? What is the temperature coefficient of resistance? It is denoted alpha, which is defined as change in resistance per original resistance per change in temperature. A silver wire has a resistance of 2.1 ohm at 27.5 degrees centigrade and a resistance of 2.7 ohm at 100 degrees centigrade. Determine the temperature coefficient of resistivity of silver. From problem, the given data, temperature T1 27.5 degrees centigrade, T2 temperature 2 100 degrees centigrade. Resistance 1 means resistance of a conductor at initial temperature or 27.5 is 2.1 ohms. R2 resistance at 100 degrees centigrade 2.7 ohms. Here what we have to find? Temperature coefficient of resistance we have to find. So what is the formula? What is the formula? So alpha is given by R2 minus R1 divided by R1 into T2 minus T1. T2 minus T1. So what is R2? 2.7 minus R1 2.1 divided by R1 2.1 into T2 minus T1. 100 minus 27.5. 27.5. Okay. So by calculation we can get temperature coefficient of resistance is 0.0039 centigrade inverse. 0.0039 centigrade inverse. Okay. So from what is the final answer? Temperature coefficient of resistance for silver is 0.0039 centigrade inverse. Drift velocity of electrons and the origin of resistivity. Coming to the content, drift velocity of electrons and the origin of resistivity. Coming to definition of drift velocity. Definition of drift velocity. Drift velocity is defined as the average velocity of electrons inside the conductors under the influence of an external electric field. What is the drift velocity? Drift velocity is defined as the average speed or average velocity of electrons inside the conductor under the influence of external electric field. Drift velocity, it is denoted V suffix D. It is denoted V suffix D. So inside the conductor, the value of drift velocity of electron is approximately 10 power minus 4 meter per second. 10 power minus 4 meter per second. Okay, so consider a conductor. This conductor having number of free electrons. These free electrons are moving in random direction inside the conductor. Okay, here the free electrons are moving inside the conductor is random motion. Random motion means zigzag. Okay, here consider at one point, consider a point and consider a cross section area. Okay, so without external electric field, the electrons are traveling from one direction to another direction. So here the electrons are moving rightward and leftward. Okay, so consider at one point here the number of electrons or the number of charges is crossing at any one point which is equal to the number of electrons or charges moves rightward and the number of electrons moves leftward, both are equal. Here the electrons are migrated one place to another place. same the number of electrons or charges moving opposite to the direction at a point. Here net charge is 0. Net charge is 0. Okay, so the charges which are moving leftward, which is equal to the charges which are moving rightward. Okay, so net charge is 0. If net charge is 0, net current also 0. Net current also 0. Okay, net current also is 0. If we can apply external electric field, if we can apply external electric field, if we can apply external electric field, that external electric field E is equal to potential difference per unit length of conductor. The length of the conductor is L. Okay, understand? Here we can apply V, potential difference. Now, the direction of potential difference is rightward. It is denoted V. Okay, understand? Now, under the influence of external electric field, okay, what happened? The electrons are moving in regular manner, like this. The electrons are moving like this, ordered motion. In previous condition, the electrons are charges moving random direction, random motion we can say. Here, under the external electric field, the electrons are drifted one place to another place. Okay, so the direction of electrons inside the conductor is opposite to the electric field. Okay, opposite to the electric field. Now we know that here we can connect a cell or battery. Okay, so we know that cell means cell, it is a device which converts chemical energy into electrical energy. This electrical energy, it produces electric field. Okay, electric field. We can say that electric field is potential gradient. Potential applying between 2 points of unit length wire. Okay, so this potential cause the electric field. This electric field cause the electrons are drifted one point to another point, one point to another point. Okay, so if electrons are moving from one direction to another direction, okay, the force, due to the force, this electric field cause the force which is required to move one point to another point inside the conductor. The force is due to electric field which is equal to F is equal to minus QE. Okay, here we can take charge Q and E, electric field. F is equal to minus QE. Okay, so we know that charge Q is equal to NE. Here N is equal to 1. N is equal to 1. Then we know that Q is equal to N. NE. Q is equal to E. Okay, so we can rewrite that equation. F is equal to minus EE. Equation 2. Okay, so how much force is acting on the electron? Okay, F is equal to minus small e capital E. Here, why we can take minus means the direction of electrons which is always opposite to the electric field. Understand? That's why you can take negative sign. Negative sign. What is the charge? Charge of electron. E is charge of electron. Capital E, electric field. Capital E, electric field. Okay. So according to Newton's second law, according to Newton's second law of motion, F is equal to ma. F is equal to ma. Okay, understand? From both equations, we can write ma is equal to 2 and 3. F is equal to ma, that is equal to minus small e capital E. From this, a is equal to minus e capital E by m. Okay, this is the acceleration of electron inside the conductor when we can apply potential difference V. When we can apply potential difference V. A is the acceleration. That acceleration of electrons or charges inside the conductor is A is equal to minus small e capital E by m. Okay. Now, so this acceleration cause the electrons are in motion or charges. Electrons are charges which are in motion. According to what is the last equation? A is equal to minus small e capital E by m. This is equation 4. Okay. So according to kinematic equations. So we know that V is equal to U plus AT. V is equal to U plus AT. So here we can take the number of charges. Here we can take the number of electrons. See, consider one electron. That one electron final velocity is v1 and the initial velocity is v1. Acceleration is a and time is t1. Okay, so consider another electron. So and so on n electrons. V2 is equal to U2 plus a t2 and so on. Vn is equal to un plus a into tn. Okay, understand? So we can define drift velocity, the average velocity of all electrons or charges under the influence of external electric field. Okay, the average velocity, drift velocity, average final velocity. These are final velocities. V1 plus V2 plus V3 plus and so on Vn divided by number of electrons. Vd is equal to V1 plus Vd is equal to U1. V1 is equal to U1 plus a T1 plus U2 plus a T2 plus and so on plus Vn divided by n. Un plus a Tn. Okay, so rearrange this equation. Vd is equal to U1 plus U2 plus and so on Un by n plus a into T1 plus T2 plus T3 and so on plus Tn divided by n. Okay, here the average initial velocity of electrons is 0. Okay, understand? The average initial velocity of electrons is 0. Okay, so we can say that is thermal velocity of electron inside the conductor in the absence of external electric field. So even though in the absence of external electric field, the initial velocities of all electrons is average velocity is 0. The average velocity of initial is 0 plus A. This T1 plus T2 plus T3 plus and so on Tn by n, we can say average relaxation time. That is denoted tau. Okay, here Vd is equal to drift velocity. It is called drift velocity. A, acceleration of electrons. Here T is relaxation time. The average relaxation time. The average relaxation time is defined as the time taken by the electrons between two successive collisions, or the time taken by the electrons or charges between two successive collisions. We can say that is relaxation time. Okay, so Vd is equal to, what is acceleration? A is equal to minus small e capital E divided by m. Okay, here E means charge of electron, E is electric field, m is the mass of electron, small e capital E divided by m, then T. So this is the expression of drift velocity. This is the expression of drift velocity. Vd is equal to minus small e capital E by m into tau. We can say tau is relaxation time. So what is the drift velocity now? What is the definition of drift velocity? The average velocity or the average speed of electrons under the influence of external electric field. Okay, so drift velocity Vd is equal to minus small e capital E divided by m into tau. Here drift velocity of electrons is opposite direction of electric field. Drift velocity of electrons is in the opposite direction of external electric field. Okay, understand? Minus gives the direction of velocity, drift velocity opposite to the external electric field. Okay, so finally drift velocity Vd is equal to small e capital E divided by m into tau. The order of drift velocity inside the conductor under the influence of external electric field is 10 power minus 4 meter per second. Coming to relation between drift velocity and electric current. Relation between drift velocity and electric current. So what is drift velocity? The average velocity of all electrons or all charges inside the conductor under the influence of external electric field. Coming to what is current, we know that the rate of flow of charges per unit time is called electric current. According to previous expression, drift velocity is equal to small e capital E divided by m into tau. Vd, drift velocity, small e charge of electron, capital E electric field, m mass of electron, tau relaxation time. Tau is called relaxation time. Then what is current? Current I. What is current? The rate of flow of charges per unit time, any cross section area is called electric current. So what is the formula? Yes, Q by T. Okay. So now we have to find the relation between drift velocity and electric current. Okay. So consider a conductor cross section area A, and length is L. Then volume of the conductor is equal to area into length. Okay, so here this is conductor. In this conductor, what is the total charge? Total charge Q is equal to number of electrons and charge of electron and into volume, area into volume. Okay, so total charge, here we can say number of electrons, charge of electron, area of cross section of the conductor, length of the conductor. Okay, from this how we can find current? Both sides we can divide it by with T. Q by T, I is equal to Q by T, then NEA L divided by T. Okay, understand? NEA L by T. Okay, so we know that length by time. Here length of the conductor divided by time, which gives the drift velocity. Here Vd is equal to L by T. Rearrange this, I is equal to NEA Vd. Okay, Vd is equal to L by T. Current I is equal to NEA Vd. What is N? Number of electrons. What is E? Charge of electron. What is A? Area of cross section. Then what is Vd? Drift velocity. Okay, so now this is the relation between drift velocity and electric current. Drift velocity and electric current. Finally, we can get the relation between current and drift velocity is I is equal to NEA Vd. I is equal to NEA Vd. Okay, so now here Vd is equal to small e capital E by m into tau. Now, from the last relation, I is equal to NEA VD. Okay, so we can substitute drift velocity in this current. We can get current I is equal to NEA VD. E capital E by m into tau. I is equal to E N E into E square A and by m into E tau. I is equal to N E square A E into tau divided by m. Okay, so from this what is the relation between drift velocity and electric current? I is equal to NEA VD. I is equal to NEA VD. So then finally we can get current I is equal to N E square A E tau divided by m. So this is the relation between drift velocity and electric current. Coming to next problem. Estimate the average drift speed of conduction electrons in a copper wire of cross-sectional area 1.0 into 10 power minus 7 meter square, carrying a current of 1.5 amperes. Assume the density of conduction electrons to be 9 into 10 power 28 meter power minus 3. On the above problem, the data they given area of cross section. Area of cross section 1.0 into 10 power minus 7 meter square. Current 1.5 amperes. Electron density means number of electrons. 9 into 10 power 28 meter power minus 3. So from the above problem, what we have to find that is drift velocity. Drift velocity. Is there any formula to find drift velocity? Yes. The formula is I is equal to NEA VD. Then VD is equal to VD is equal to I divided by NEA. Okay, understand? Drift velocity VD is equal to I divided by NEA. Now, what is current? Yes, 1.5 divided by N electron density 9 into 10 power 28 into charge of electron 1.6 into 10 power minus 19. Okay, so E is fixed value 1.6 into 10 power minus 19 coulombs into area 1.0 into 10 power minus 7. 10 power minus 7. Okay. See here, after getting cancellation, we can get 1.042 into 1.042 into 10 power minus 3 into 10 power minus 3 meter per second. Okay, so after cancellation we can get the answer 1.042 into 10 power minus 3 meter per second. Okay, so what is the answer? Drift velocity is equal to 1.042 into 10 power minus 3 meter per second. Coming to mobility. Mobility, it is defined as it is the ratio of drift velocity per unit electric field. It is defined as drift velocity of a charge per unit electric field. Okay, so according to definition, mu is equal to drift velocity divided by electric field. Drift velocity of charge per unit electric field. Then coming to the expression. So we know that Vd is equal to, what is the formula of Vd? Vd, we know that small e capital E divided by m into tau. So we can substitute this equation from above. Mu is equal to E capital E tau divided by m divided by E. E gets cancelled. Small e tau divided by m. What is small e? The charge of electron. What is tau? Relaxation time. What is m? Mass of the electron. Okay. So it is a positive quantity. SI units. Its SI unit meter square second power minus 1 volt per minus 1. Okay, understand? This SI units meter power 2 second power minus 1 volt power minus 1. Dimension formula. What is the charge? Charge of electron. Dimension formula of E is a power 1 t power 1. Then time t power 1 divided by m mass m power 1. Rearrange this m power minus 1. There is no length, that's why L power 0 t power 1 t power 2. And finally a power 1 is there. Drift velocity dimension formula m power minus 1 L power 0 t power 2 a power 1. Okay, so what is the definition of mobility? Drift velocity of charge per unit electric field. It is denoted mu. Mu is equal to Vd by E according to definition. Okay, understand? So then, what is the dimension formula of drift velocity? Very important one. M power minus 1, L power 0, t power 2, a power 1. Okay children, by this we complete this session, and I hope all are clear with discussed topics. Here I am giving you some questions as a homework. Complete it by tomorrow and submit in WhatsApp group. In case of doubts, WhatsApp me to 9295551976. WhatsApp me to my mobile number 9295551976. Coming to homework. First question, define current density, write its SI unit. Is it a scalar or vector quantity? Second question, A. Define resistance of a conductor, write its SI unit. B. What are the factors on which the resistance of a conductor depends? Third one, A. Define resistivity of a conductor, write its SI unit. B. On what factors does the resistivity of a conductor depend? Fourth one, derive an expression for drift velocity of free electrons in a conductor in terms of relaxation time of electrons. Fifth question, deduce the relation between current flowing through a conductor and drift velocity of free electrons.